this tutorial, we are discussing about part of speech tagging in NLP. So, what is part of speech tagging? So, POS tagging basically in NLP, the process of assigning parts of speech to each word in a given sentence. And the part of speech include categories like noun, verbs, adjectives, adverbs, pronouns, preposition, conjunction, and interjections. So, here we basically import it the part POS tagging, and we basically import the word tokenize. So how POS tagging works, basically we give you a brief idea at first. So at first we tokenize the word, that is the text split into individual words or tokens, and after that each token is assigned a POS tag based on its definition and context within the sentence. So here we do the same. So we give the text and tokenize at first, and after that we basically POS tagging. We give the text tagging, and the output we see that the SRF is NNP, that is that is noun, and after that the VBZ means verb, and DT means delimiter determiner, so, sorry, determiner, and computer NNP, that is a noun, and platform NN, that is also a noun, and yeah, that's it. And after that we will discuss the word embedding in NLP. So what is word embedding? Word embedding is an approach for representing words and documents. Word embedding or word vector is a numeric vector input that represents a word in a lower dimensional space. It allows words with similar meanings to have a similar representation. Word embeddings are a method of extracting features out of the text, so that we can basically input those features into a machine learning model to work with text data. They try to preserve basically syntactical and semantic information. The methods such as bag of words, count vectorizer, and TF-IDF rely on the word count in a sentence, but do not save any syntactical or semantic information. In these algorithms, the size of the vector is basically the number of elements in the vocabulary. We can get a sparse matrix in if most of the elements are zero. Large input vectors will mean a huge number of weights, which will result in a high computation required for training. So word embeddings gives us a solution to these problems, and many more embedding techniques are there. That is, at first we discuss one hot encoding. So one hot encoding is a simple method for representing words in NLP. In this encoding scheme, each word in the vocabulary is represented as a unique vector where the dimensionality of the vector is equal to the size of the vocabulary. The vector has all elements set to zero, except for the element corresponding to the index of the word in the vocabulary, which is set to one. And this code basically defines that. So we first create a one hot encode function by defining the one hot encode and gives that text. And after that we basically here we create some doing the necessary stuff for returning one hot encoded text. So basically we gives the text, and it gives us the basically it returns us the numbers that computers understand. So we get that, right? So we get that we give the desired word, that a cat in the hat, dog on the bat, mat, bird in the on the tree. That is a word not encoded matrix. We give basically cat in the hat, one and zero. It's basically binary number. After that, the bag of word is one of the technique. Bag of word is basically text representation technique that represents a document as an unordered set of words and their respective frequencies. It discards the word order and captures the frequency of each word in the document and creating a vector representation. So bag of word, we basically import from sklearn library. So sklearn.feature extraction, text, we basically import a count vectorizer. So we give the document doc and after that we basically create an object that is of the count vectorizer, and after that we pass the document here, and we basically after that we basically print the array I mean the print a bag of words, and it we turn it into to array. So we gives us the bag of word matrix, and after that we gives us the vocabulary, that is, and document first is one of the second, that is the word. So yeah, and after that we also discuss the TF-IDF part, that is term frequency, inverse document frequency, and we also import it from the scalar library, that is TF-IDF vectorizer, and exactly same as previous, that we give the document and we create a tf idf vectorizer, I mean the create a object, and after that we fit and transform the document in the model, and we vectorize it, and after that we basically loop we basically run I mean run a for loop, and we enter the document part, document index and document, and after that with tf-idf matrix we basically we want to create a tf-idf matrix, and yeah, tf-idf matrix, and we after that we print out the tf-idf document. uh, so we get the tf-idf, it basically gives us a continuous value, not a matrix. It basically gives us a continuous value. So dog, lazy, it's get out the not it gives us the matrix, it gives us the continuous value. So we get that, and yeah, uh, that is it, guys. So yeah, thank you.